So today we are going to discuss about a technique known as basically it is known as dimension reduction. One question come, what is dimension reduction? Let's say we have conducted a survey. We have taken a survey questions are there. Let's say 30, 40 questions we have taken. But we don't know that which of the question or the items, basically we call them items. First thing, which of the items are relevant to our study and which of the items are not relevant. First thing. Second thing, that few of the items might be measuring some underlying constructs or underlying dimensions. Which of the question measure those dimensions? We are unaware of it. We don't know. Or even if we know from literature review that okay, these 10 questions will measure a particular dimension, still we have to cross validate whether it is the case in our sample or not, because that study has been done in some other context and you are doing that study in a different population, different context, or a different sample. So first thing is to identify the relevant items and remove those items which are not relevant to your study or not measuring your objectives. And second thing is to group these items as per the dimensions or the constructs they measure. This entire technique is known as dimension reduction. Then breaking it down, we call it as factor analysis. Now, this factor analysis is of two types. Probably it is three, four types, but basically what we practice is principal component analysis, and exploratory factor analysis. Now, here is a catch. Most of the people they do one mistake, and that mistake is that they report that they are doing exploratory factor analysis, but by mistake they do principal component analysis. And I'll show you how they do it. First, we need to understand what is the difference between the principal component analysis and exploratory factor analysis. Both are dimension reduction techniques. Only thing that changes is the choice of the method, that whether we should go for principal component analysis or exploratory factor analysis depends on variance partition. Now, variance, what is variance partition? See, there are two types of variances. Variances are of two types. Common variance and unique variance. See, if all the items are explaining one construct, only one construct, then they are sharing common variance among them. When these items are apart from explaining one construct, they are explaining something else also. pointing towards something else also, few of the items, then this is known as the unique variance of that particular item. So when total variance is explained by common variance, then then the method is known as, or method of dimension reduction is known as principal component analysis. And when total variance is explained by common variance plus unique variance, then we use exploratory factor analysis. Now, what mistake normally people do when they go for factor analysis, that without identifying that whether the total variance is explained by the common variance or it is explained by both common and unique variance, they say that we are doing exploratory factor analysis. Let's say common variance means they choose a method without identifying that total variance is explained by what. Whether it is a common variance that is explaining common variance between the items that is explaining the total variance, or apart from a common variance, few of the items also have a unique variance, means the total variance is explained by a common variance plus unique variance. Without identifying, if you are doing this, it will be wrong and you will messed up with the things. Your factors identification won't be there. There will be problem of multicollinearity. There will be a lot of problems. And most often while doing in SPSS, since by default principal component analysis is selected, without giving it a look, without giving it a thought, people say that it is exploratory factor analysis, but the method they choose is the principal component analysis. Principal component analysis is not exploratory factor analysis. The method is different. But when to decide on a method, that is totally dependent on whether, that is totally dependent on variance partition. So if your total variance is explained by common variance, let's say you have 10 questions. For measuring one particular dimension. And if all 10 questions are only and only measuring that particular dimension, or let's say 10 out of 8 out of 10 are measuring that particular dimension, 2 are measuring nothing, we will remove those 2, keep those 8, and these 8 are since measuring only that particular dimension which we are trying to measure, they are sharing common variance among them. However, out of these 8, let's say 2 or 3 are measuring that construct. Apart from that, they are measuring something else also, some underlying constructs also. Then we can say that the total variance is explained by apart from the common variance, there is some unique variance also. Then we should apply exploratory factor analysis. Any confusion on this?
Sir, when we do exploratory factor analysis, the method that we choose, usually people say that you should use principal component analysis to rotate the factors.
That is the error that they do. See, rotation is something different. I'll come to that.
Okay.
It has nothing to do with their principal component analysis or exploratory factor analysis. That's what I'm saying. When you are doing exploratory factor analysis and choosing the method as principal component analysis, you are doing error. Whatever the result you are getting few numbers, but actually that is not the correct result.
Okay, sir.
Let me take an example so that I can illustrate you better. Can you see this questionnaire?
Yes, sir.
This is SPSS anxiety questionnaire developed by Andy Field. It is having 23 items. As of now, I don't know that all these 23 items are measuring what. But finally, I want to see that all these 23 are measuring SPSS anxiety, people's anxiety towards SPSS. So he made 23 questions, gave it to the people, and then he tried to find out which are the first thing, which are the relevant questions that are measuring this SPSS anxiety, and apart from this SPSS anxiety, are they measuring something else? If they are also measuring something else, then there is a unique variance. Then the method we use will be exploratory factor analysis. Else, if all or let's say 20 are relevant and 20 are measuring this SPSS anxiety only, then it will make it a perfect case for principal component analysis. So if I, just for illustration purpose, let's say I'm taking 5 items out of it, just I'm making chart. Let's say this is the case. I have 5 items. All these 5 items, I am not going to make the 23 items, it's going to take a lot of time. Let's say for illustration purpose, I have 5 items. All these 5 items are measuring SPSS anxiety only. So what is the case? This total variance SPSS anxiety is explained by common variance, isn't it?
Yes,
Yes,
sir.
sir.
All are pointing towards SPSS anxiety. So this is a common variance. So all are measuring common, all are the cases of common variance. So which method we will apply here? Total variance is explained by common variance only.
So PCA.
It will be PCA. And what is our purpose? Only to identify which out of these 5, which are the relevant items that are measuring SPSS anxiety. Clear?
Yes, sir.
So if the case is that the total variance is explained by common variance only, and in that case we want only to identify that which are the best predictors or which are the best measurement of SPSS anxiety or our outcome, then we will perform PCA. Let's say 3, 4, or maybe all 5 might be explaining SPSS anxiety. After PCA, we will come to know about it. Now consider the second case. Just let's have a look at the example. All these 23 questions we have taken to measure SPSS anxiety. But if you see this question, I have little experience of computers. Okay? All computers hate me. That, but are they measuring some underlying construct also?
Yes, sir.
Yes. Any answer?
Yes, sir.
What?
Yes, sir. Yes,
What?
sir. My knowledge towards computer.
Knowledge towards computer or technical anxiety, can we name it?
Yes.
Or computer anxiety, can we name it?
Yes, sir.
Right?
Yes, sir.
Now let's see this. Statistics makes me cry. Standard deviations excite me. Apart from SPSS anxiety, it is measuring something else.
Yes, sir. It is in the statistics anxiety.
Statistics anxiety. So there are some underlying construct which they are measuring. So let's put it item 1, item 2. Let's remove this. If this is the case, then I am renaming it item 1, item 2, item 3, item 4, item 5. I will add 2, item 6 and item 7 also. Item 7. Now let's look here. Statistics makes me cry. Item 2 is, my friends will think I am not, this is directly related to SPSS anxiety. So as of now, I'm discarding this for purpose. I dream that Pearson is attacking me with correlation coefficient. Again, statistics anxiety. I don't understand the statistics. Statistics anxiety. I have little experience of computers. All computers hate me. Statistics anxiety. Now the case is different. Now, four items are measuring statistics anxiety. Item 6 and 7 are measuring computer or technical anxiety. In return, all these are measuring SPSS anxiety. Now, the total variance is explained by what? A common variance among these plus unique variance also. Are you getting my point?
Yes, sir.
Yes, sir.
So, if this is the situation, then common variance plus unique variance. I think this is might be new for you because I haven't seen any of the lectures explaining that why PC, when to use PCA and when to use EFA. All people they mix up EFA and PCA. Both are dimension reduction technique, but difference is there. And you will find such kind of structures like in this questionnaire. Then you have to perform EFA and method is different. Otherwise, you are doing some error. So now the total variance of stress anxiety is explained by common variance. All these, plus they are also explaining some other dimension, that is unique variance. Now the total variance is explained by common variance of this, common variance of this, plus unique variances of all these. Then as we will use EFA. Is it clear?
Yes, sir.
Is this concept clear when to use EFA, when to use PCA?
Yes, sir.
Still, if there is any confusion, I can explain. I've given you two examples. All my questions, or few of them are means those who are relevant. If they are measuring only and only measuring the final outcome that we want to measure, then that is the case of total variance explained by common variance. We will perform principal component analysis. If apart from measuring the main outcome, they are also measuring some other dimension, underlying constructs, some other underlying constructs, then they have, then the total variance is explained by a common variance plus unique variance of underlying constructs. Like this set figure is there. In that case, like our questionnaire is telling us, in that case, you will apply exploratory factor analysis. So if you see our these 23 questions, which of the method should we adopt? PCA or EFA?
EFA, sir.
Exploratory.
EFA. Now, this is done in two steps. EFA or PCA, whatever you are doing, done in two steps. First one is factor extraction to identify relevant factors. Second one is factor rotation to have better interpretability. If it's principal component analysis, then you will replace this word factor with component extraction and component rotation. That's it. Now let's see this data has already been filled. So data, you can open saq.sav file. Confirm me once you have opened it. Is it open? Should I proceed further?
Yes, sir.
Sir, just a minute, sir.
Okay, okay, fine.
Yes, sir. Kindly proceed, sir.
Okay. Now the very first step for doing either principal component analysis or exploratory factor analysis is to test for two assumptions. First one is KMO test of sample adequacy. Kaiser-Meyer-Olkin test of sample adequacy. Second one is Bartlett test of sphericity. If both situations are fulfilled, then only we should proceed for factor analysis, be it PCA or be it EFA. So first to test that, go to analyze this dimension reduction factor. Select all your variables. Okay, all 23 items. Go to descriptives and here select KMO and Bartlett test of sphericity. Continue. Okay. So this KMO test should be close to 1. The more it is closer, normally we say it should be greater than 0.5. More closer to 1, for far better, but it should be greater than 0.5. If it is greater than 0.05, then sampling adequacy is there. This is the first assumption that is fulfilled. Second assumption is Bartlett's test of sphericity. This should be significant, means value should be less than 0.05. Are we getting these two?
Yes, sir.
So these two assumptions of applying factor analysis are fulfilled. First thing. Now, why we are doing this factor extraction and rotation? Because we have variables, we don't know which of them is independent variable, which of them is dependent variable. We have only items. What they are measuring, we don't know. In which direction they are going, we don't know. What dimension they are measuring, we don't know. So to assess this and which of them is relevant, that also we don't know. We have an objective. For that objective, we have made questions, but we don't know whether that objective is going to be fulfilled or not by these questions. Actually, this should be done, this reliability test, validity test, and dimension reduction should be done at the pre-testing stage of the questionnaire. Now, what is meant by Kaiser-Meyer-Olkin sampling adequacy? This you will achieve only when you have the minimum sample size. And for any of the test, and for particularly EFA, the thumb rule is that there should be item to response ratio should be 1:5 minimum. That means for each individual item, minimum 5 responses are required. Then only you will be able to achieve KMO sampling adequacy results. So if you see our questionnaire, 23 questions are there. So minimum how many response do we need? Minimum
23
23.
into 5,
The
115.
115.
This was the minimum requirement.
Yes, sir.
How much do we have?
200? No, it's more than that.
257,
2571.
257. And that's why our this is due to such large sample size. Minimum requirement was 1 is to 5. It's far beyond that. If it is less than 1.1 is to 5, normally it will chemo test will not. This assumption will not be fulfilled. That's why it is very close to 1.930 because we have so much large sample. So from where does it comes? By calculating the minimum requirement, that is 1 is to 5. And this is known as item to response ratio. This was given by Cochrane, because site also given by another author, Uma Sekaran, and Doogie. I'm not sure, you can cross check with the internet, but probably it was given in 1994. Let me check. Let it be clear here only. So you can cite the latest one, that is 2019 in their book. They have test. They have given this. Back it was given in 84 also, I believe. Yeah, in 1983 they have given. She has given this in this article. Fine. So minimum 1 is to 5 is required. So since we have large sample size, so we are getting, means the value should be greater than 0.5. We are getting very high value due to large sample size. And our Bartlett test of sphericity also stands to be significant. So we can say that we can proceed with the dimension reduction or factor analysis. And given the nature of our questionnaire, we identified that we should do EFA. The first step of factor analysis, whether it's EFA or PCA, is factor extraction or principal component extraction, to know which are the relevant items. And they will converge to how many factors. So how many factors to extract? Do we know this?
No, sir.
Are we aware of this?
No, sir.
At this point of time, do we know how many factors to extract? These 23 items will converge to how many factors? Do we know?
No, sir.
We don't know. So what we will do, we will go to analyze. We will check them based on eigenvalues. So any eigenvalue greater than 1, we will put the criteria greater than 1 eigenvalues. So if you go to dimension reduction factor, all these 23 items are selected. Extraction. See what people do. They are doing exploratory factor analysis, but by default, this is principal component selected. They don't pay heed to this and proceed. So in the heading, it is written exploratory factor analysis. In the table which SPSS make and which you copy and paste as it is written principal component analysis. And then we get the error. So if you have to do principal component analysis, all steps will be same. Only thing, choose the method. So if you have to do exploratory factor analysis, you have to take principal axis factoring method, not principal component method. If you have to do principal component analysis, then only this method, else principal axis factoring. Select this scree plot, which is the visualization, and keep this eigenvalue. So eigenvalue is greater than 1. We will take only those factors, those number of factors, till where eigenvalues, which is the goodness of the fit, okay, we will take this into account. Are you getting the point?
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
And script plot will be the visualization of these eigenvalues only. Based on the eigenvalues, script plot will tell you how many factors to extract. And if you see, there are two elements in this principal component analysis or exploratory factor analysis. That is the eigenvalues, because it's all based on the choosing the number of factors is based on the eigenvalues itself. Only criteria is the eigenvalues. So we have the eigenvalues and eigenvectors. So this eigenvalues actually represent the total amount of variance that can be explained by a given factor, and eigenvectors is the weight for each particular eigenvalues. So as of now, don't go into that detail. Simply understand that when we do factor analysis, we keep eigenvalues minimum 1. If any eigenvalues is less than 1, we won't choose that factor. And here, maximum iteration for conversion. If you have a large sample size, by default it is selected 25. For better, if you have a large sample size, you can put the maximum number of iterations for convergence that can be done by SPSS, and that can be 100 iterations. So by default is 25. If you have sample size like 300, 400, keep it 25. We had a large sample size, so we will keep a maximum iteration. So there should be broader scope for iterations to happen. And always remember, here we will choose principal axis factoring method, not principal component method. Because our items, they are measuring some underlying constructs also apart from measuring the main construct. Okay. Since we do not know how many factors to extract, if we already know based on our literature review. Literature review is saying that, okay, out of these 23 questions, 5 will fall into this category. I think I lost the connection. Now am I audible?
Yes, sir.
Then I checked that I got disconnected. So where were we? Factor extraction. We were at factor extraction, right?
Yes, sir.
So
Sir,
have you?
you were telling about that eigenvalue.
Okay.
You kept it 100. After that,
No, 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 no,
I
no.
lost you.
Eigenvalues I didn't kept at 100.
Iteration was at 100, eigenvalue was 1.
Yeah, sorry.
Yeah.
Iteration value
Since
was 100.
since I am in extraction, I am not this step. Are you clear that we have to select principal axis factoring?
Yes, sir.
Okay. So we will, as of now, since I am not knowing that how many factors to extract, so I will keep eigenvalues as the criteria. So normally eigenvalues greater than 1 are considered. If I am using some questionnaire which is previously been used and validated and its factor analysis is done, already it has been arranged as per the factors. Then again, if I am using, I know okay, 3 or 4 factors are there, or from literature review also it is suggested, then I can select fixed number of factors. How many? But since I don't know, so I will select eigenvalues as the criteria. And iterations for conversion by default, it is kept at 25 by SPSS. Given large sample size, you can keep it to maximum. Okay, since we have 2500 observations, so why to limit the number of iterations? Better keep it to the maximum, which is 100. Is that clear till now?
Sir, if I am using a tool which has been previously validated,
Uh,
and so I can fix the number of factors.
of
Maybe
course.
in our culture, it may not come to that number of fixed factors.
See, if you are very sure, then you can go for. Otherwise, the preliminary step is to based on the eigenvalues you have to select.
Okay, so I can take in that case also I based on the eigenvalue, even if that
Ah,
has been validated
see,
previously.
this is the preliminary check. If you
Okay.
are very sure that okay, or if you are using the questionnaire as it is,
Yeah.
without any change, then you need not to first you need not to do factor analysis even. Why you will need? Why you will
Yeah.
need to
Yeah.
do? Are you
Yes.
getting my point?
Yes, sir. Yes, sir.
Only you have to establish its validity in the next step, that is confirmatory factor analysis, to confirm that whether in your setting, because let's say you have taken a questionnaire which was surveyed in US. So population of US is very different from the population of India in many terms. Let's say if you are doing taking some cultural elements, it will be pretty different, isn't it?
Yes, sir.
So in that case, you have to do confirmatory factor analysis, or at this step also you can do the validity. Already if factors are identified, then there is no need of doing this factor analysis unless you are adding or deleting few questions. If you are doing modification, then again you have to do factor analysis or principal component analysis. And first step of factor extraction is to know how many factors to extract, because as of now I don't know out of 23 questions how many factors I can extract. Okay.
Okay, sir. So even if I am translating the tool in a Hindi language, even then I will have to do EFA.
No. That won't make a difference. I am
Okay.
saying if you are adding or deleting few items,
Yes, sir. Yes, sir.
okay, then that will make a difference. Translation won't make a difference.
Okay, sir.
But always it's a better idea to cross check it through confirmatory factor analysis. At least test its validity when your population is changing. Right? Might be when you are translating it for Indian people, they might think that question in a very different manner as compared to the US person.
Yes, sir.
Are you getting my point?
Yes, sir. Yes, sir.
Yes, sir.
Due to the cultural differences, they might not be comfortable with few of the questions. So if you are modifying, please, or even translating as it is, then no problem. But if you are modifying, adding or deleting few items, then of course you should do factor analysis. Okay. So first is factor rotation, and I don't know how many factors to rotate. Extract factor extraction. So I will keep the criteria of eigenvalues. Continue. Okay. Now from this table, can you tell me how many factors have eigenvalues greater than 1?
Sir, it's 4.
4. And maximum variance explained by these 4 factors is
40%.
40%. So we can take 4 factors. Clear?
Yes, sir.
Now let's look at the scree plot. See, at this scree plot, influx is happening at 2 points. Second factor, can you see here there is a sudden influx, right?
Yes, sir.
Then at the 4th point also there is a sudden influx. After that you see all are in the same line, but at 2 points influx is happening. Second and 4th, isn't it?
Yes, sir.
So it is suggesting that you can either converge it or extract 2 factors or 4 factors. This is what telling me maximum you can extract 4. This is telling me you can either extract 2 or extract 4. So we have the choice of either, because at the points where influx will happen, we can take maximum of those factors. So at 2 also a sudden influx is happening, so we can take 2 also. At 4th point also it is happening, so we can take 4 factors also. However, given 23 questions, large sample size, and this suggestion and good number of variance is also explained. Suppose if there is no much change in variance from second to fourth, then of course we can take 2. But for safer side, we will take 4. Because if you see, we take 2, only 33% variance is explained. If there is no change in taking the fourth and till 4 and there is no change in variance, then of course we can be satisfied with 2. But since 7% of change in variance, which is a good number, so we can, for a safer side, we can take 4 factors to extract. Is this clear?
Yes, sir.
So how
Now,
how
yes,
do we know that which factor correspond to what? For example, factor one, is it SPSS anxiety? That's how we relate it.
I have not come to that point till now.
Okay.
I will show you how to will know. As of now, I am only deciding on how many factors to extract. Okay,
Okay.
based on eigenvalue and scree plot. Now I will be doing, when I will be doing rotation, then it will be very clear to you.
Okay.
The question that you are asking. I will, of course, identify and name all these 4 factors and their corresponding values. Now again go to dimension reduction factor. Now go to extraction. Now here we can choose fixed number of factors, because eigenvalue criteria has told us 4 factors we can take. Now we will take 4 factors. Okay. Is this
Yes,
clear?
sir. Yes, sir. Yes, sir.
Yes, sir.
Continue. In descriptives, we want correlation coefficient matrix. Where it will help, I will tell you. Okay. Univariate descriptives also you select. Chem1 Bartlett already we have selected. However, if you want to leave it, because Chem1 Bartlett criteria was fulfilled. Extraction done. Now coming to rotation, or I will move on to rotation later. First, let me show you the results of extraction. Correlation matrix I will come later on. Now this is the factor matrix. When we extracted, not rotated. Now can you see the same statistics makes me cry is loading on first also. It is loading on second also. Loading on third also, loading on fourth also. Can you see this?
Yes, sir.
So it is actually loading on which of them? We don't know. We don't know. Ideally, we should take that on which it is loading maximum, but it is showing the problem of multicollinearity also. It is loading on others also. Since it is negatively loaded on third, we won't consider third. But which one to choose? We have to see each and every table. Okay, which one is the highest? We will keep that. So interpretation is not good. Extraction we have done, but interpretation part, better interpretability we are not getting, and that's why we do the rotation. Is this clear why we do the rotation?
Yes, sir.
Yeah.
Now again go to analyze. I'm telling it step by step, otherwise I can have done it in one step, single step. Now go to rotation. Now you have quality max, vari max, equa direct oblique, pro max. See, there are two kind of rotations: orthogonal and oblique rotations. Orthogonal rotations are used when you are pretty sure that the factors are not correlated with each other. And when you know that factors are correlated with each other, means they are dependent on each other, then you should use the oblique rotation method. So broadly, there are two rotations, that is the oblique and the orthogonal rotation. However, you might be seeing 6, 7 rotate kind of rotations. So when you are, I will write it here, rotations. Orthogonal rotation and oblique rotations. Now, out of these, if you are choosing none, then this is known as simple structure. This Varimax Varimax, Equamax, and Qualtimax are type of orthogonal rotations. Whereas this direct oblique and Promax and Promax are oblique rotations. We do rotations for having better interpretability, because only factor extraction won't yield any helpful result. That we have seen, it is showing that one factor is loading on many. Now, when to choose orthogonal rotation and when to choose oblique rotation. So if you are sure that your factors are independent of each other, after seeing your questionnaire and all, then you should choose orthogonal rotation. And if you know that your factors are dependent or correlated with each other, then you should choose oblique rotations. The most preferable kind of orthogonal rotation is Varimax, whereas most preferable kind of or most widely used this oblique rotation is direct oblique. So, so after looking at the questions, can you tell me which of the rotation method we should use, orthogonal or oblique?
So oblique rotation.
How come? How come oblique?
Because the factors are dependent on each other.
How come factors are dependent on each other?
Underlying factors are ultimately deriving the
See,
final.
see. Are these questions related to each other? Some are pointing towards mathematics, some are pointing towards computer, some are pointing towards statistics. Are they related to each other?
No.
They are not related to each other. Of course, they are not. So, which one to choose?
Then Varimax.
Then orthogonal rotation, and in that, Varimax is most widely used. So, you should have logic for everything. So, Varimax rotation. Again, here, maximum iterations 100. Continue. Scores. If you want to save as variable the standardized scores, because you don't know which of, because now you will be converging 23 questions on 4 factors. What will be the score? You have the score on a scale of 5 for each individual item. What is the score of the particular factor? Are you getting my point?
Yes, sir.
So for that you will select, and that was ordinal scale. Now, if you want to convert it into continuous measurement and want to know the score also for a particular construct, because as of now we were knowing only the value of individual items, what respondents have given. What is the value of, let's say, 5 questions are, I will show after rotation, 5 questions are related to factor 1. What is the score of factor 1? So you have to select factor score, and you can choose any of these methods: regression, Bartlett, Anderson, Rubin. If you are doing factor analysis for the purpose of regression, then better you choose regression method. If you are using for any other analysis, better choose Anderson, Rubin method. Continue. Options here. Suppress small coefficients. What should be the value? Those who have done factor analysis earlier, what should be the value?
So it should be 0.4.
Why?
The reason I don't know, but I just know that it should be 0.4.
Some of the people say 0.3.
So some say that it should be 0.3 or 0.4.
Yeah,
Both are used.
both are used. So some people without any logic has told us, so we are keeping it as 0.4. There is a logic behind it. And what is that logic? See this statement, what it is. Suppress small coefficients below a value. What is the maximum variance explained?
40%.
If you convert it into decimals, how much it will come?
4.4.
0.4.
Yes.
So don't say, assume that I am saying 0.4 on because others have said. If it is 50%, then I will keep it as 0.5.
Okay.
Why I am doing this? Because maximum variance explained is how much?
40%.
or 0.4, right?
Yes.
So why I will take those factors which are unable to explain the variance? Is there any reason behind taking those?
No.
No. So that's why I will keep it 0.4, means the maximum variance explained could is 40% or 0.4. So all those others which are unable to explain the variance will be removed. Now you got the rationale behind it, logic behind it.
The factors are
Yes, sir.
explaining
Yes,
point.
sir.
Yeah,
The maximum variance explained
is point 4.
is 0.4. If it has been 0.5, then I could have put it 0.5
Point
here.
4. Yes.
If it is 60%, then I will put it
Point
0.6
6.
here, because maximum variance explained is, let's say, 60%. So why I will choose those variables which can't explain this 60% variance? So I will remove all those whose coefficient score is less than 0.6. In our case, it's 0.40%. Maximum variance is explained. So I will keep it as 0.4, right?
Yes, sir.
Not because others have said. This is the logic. Continue. Now, okay. All those things will be repeated, but let's go. Now, this was the factor matrix, not clear interpretability was there. Now, rotated factor matrix. Can you see it's clearly structured right now? No problem of multicollinearity is there,
Yes, sir.
right? Now, let's see one by one. Question number one, loading on which factor?
1.
So, let's put it here. 4 factors we had. Let's name as factor 1, factor 2. Now somebody asked me, sir, how to know? I think we are moving in that direction.
Yes, sir.
4. And how to name this factor, that also I will tell you, don't worry. Now on factor 1, let's see which question is loading. 1, right?
Yes, sir.
This is loading on factor 1. Second is not loading here. Third is a negative value, we will discard. Fourth one is loading here.
Yes, sir.
So question number 1, question number 4, we will write like this. Question 1, question 4. First, second, third, fourth, fifth. Fifth is loading on 1.
Yes, sir.
Question 5. Question 5. Then this is which question? You have to see this. People try to tell you that SPSS make statistics easy. Question 12. Then I weep openly at the mention of central tendency.
Sir, 16.
16. Question 18. Then I can't sleep for thought of eigenvectors.
Sir, it's 20.
20.
Yes.
Anybody is having the PDF copy of this I shared? Can you please help me with the questions? Question 20. Then 21.
Yes,
Okay?
sir. 21.
Question 21. Question 20. Now come to factor 2. This, I have little experience of computers.
It's 6.
Question 6.
Yes, sir.
Question 6. Question 7. All computers hate me. Isn't it? It is question 7, right?
Yes, sir.
Okay. Then this one, actually, this question is loading on 2. This is only one case of multicollinearity. So we have already taken it because it was having highest loading here. So we will discard from here. We won't take here. This one,
So 13.
question number 13.
13. Yes, sir.
Question number 13. Then this is question number 14.
Yes.
Yes, it's 14.
Question number 14. We have taken, this one is 14. Computers have mind of their own.
Yes, sir.
This one, SPSS always crashes when I use it.
So it's 18.
18.
Yes, sir.
Question number 18. That much. Now factor 3. This question, I have never been good at mathematics.
It's 8, sir.
8. 8.
Question number 8. Then this question, I did badly at mathematics at school.
So it's 11.
11.
Yes, sir.
Then I slip into coma whenever I see an equation.
17.
That's it. Now factor 4. My friends will think I am stupid for not being able to cope with SPSS.
It's question 2.
Question 2. Question 2.
And question 9.
Then
Question 9.
this, my friends are better at statistics than me.
Yes, sir.
Question 9. Okay. My friends are better at SPSS than I am.
22.
22. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many questions we had?
So it's 23.
How many were of use to us?
23. 23.
We had taken
18.
23, but finally, how many of were used to us?
18. 18.
18. 5 have been
Yes.
discarded.
Yes, sir.
How? This one,
Because
I
they
am
were
good.
not
This
loaded
is
anywhere.
this is not loaded on anything.
Yes, sir.
Similarly, this one, everyone looks at me when I use a space, it doesn't loaded at anything. One. Okay? At any factor. Computers are out to get to me, doesn't load it. Third one, we discarded. Computers are useful only for playing games, not loaded on anyone. Discarded. Fourth. And this was having negative value. Discarded. Fifth. So total 18 were of use to us. And this is how we have made the matrix. Factor 1 will consist of these questions. Factor 2 will consist of these questions. Factor 3 will consist of these questions. Factor 4 will consist of these questions. Now see these questions. Question 1, 4, 5, 12. Question 1, 4, 5, this 12. What they are talking about?
Sir,
Statistics,
statistics anxiety.
statistics, anxiety, or fear of statistics, you can say.
Yes, sir.
So this factor will be named as fear of statistics. And we'll have, now we will restructure our questionnaire where fear of statistics will consist of these questions. Now see the second one. I have little experience of computers. All computers hate me. Not this one. I worry that I will cause irreparable damage because of my incompetence with computers. Computers have mind of their own. So, fear of using computers. Is that it? Then see question number 8, 11, and 17. 8, I have never been good at mathematics. 11, I did badly at mathematics at school. I slip into coma whenever I see an equation. Fear of mathematics. Our third construct or factor having these three questions. You have to name your construct or factors by saying what is the commonality between the questions that are loading on a particular construct. My friends will think I am stupid for not being able to cope with SPSS. My friends are better at statistics than me. My friends are better at SPSS than I am. Fear of peer evaluation. Now these are the questions. These are their corresponding constructs or factors. Now you can restructure your questionnaire like this, or you can, if you are not restructuring, then also you know that factor 1 consists of these questions. 18 questions are of use, 5 are discarded, where these questions will measure factor 1, which is fear of statistics. These questions will measure factor 2, which is fear of using computers. These questions will measure factor 3, which is fear of mathematics, and these questions will measure fear of peer evaluation, which is factor 4. So now you can make the diagram like this, whatever we have made, and you can find. Now what is the score of these 4? If you see this data set, factor 1 score you got on a, now you have not got on an ordinal scale, it is a ratio scale, right? Factor 2, factor 3, factor 4. You got their overall scores based on the loadings, and now you can use this data for any kind of statistical test further. Is this clear?
Yes, sir.
Now,
Yes,
in
sir.
between, we have made a correlation matrix. What is the use of this? This tells you about validity. And already I have told you that there are two kinds of validities, convergent validity and discriminant validity. Convergent validity, there is a concept, construct and all this. Here we are trying to measure construct validity. So construct validity, for a construct validity, there should be a discriminant validity and convergent validity. Convergent validity says that items of one construct should have high correlation with each other. Discriminant validity states that items of one construct should have weak correlation with items of other construct, then discriminant validity will be there. That simply means that Q1, Q4, Q5, Q12, Q16, Q20, Q21, they should have a high correlation with each other. Q6, Q7, Q13, Q14, Q18 should have high correlation. Similarly, these one should have high correlation among themselves. But Q1, Q4, Q5, Q12, Q16, Q20, Q21 should have weak correlation with Q6, Q7, Q13, Q14, Q18, Q8, Q11, and so on. Similarly, these should have weak correlation with all these, all these, all these. Then we have discriminant validity. How you will come to know? From this correlation matrix. You can see this matrix and see that a particular question, whether all questions which are measuring one construct have high correlation among themselves. If it is the case, then there is a convergent validity. Then all questions of one construct are having weak correlation with the items of another construct. Then this is known as discriminant validity. If both validities are established, then during this process also you can know whether there is a validity or not. Reliability you can check through Cronbach alpha. So this is questionnaire done at the questionnaire pre-testing stage, and that's how you arrive at identifying dimensions, generating factor scores, identifying your factors, their relevant items or questions, and also convergent and discriminant validity. Is this clear?
Yes, sir.
So that is all for today. If any question, I